I'm excited now to introduce Mr. Mike McLaughlin, who is a Director of Technical Product Marketing, and Andrei Leibovich, who is the Vice President of Solutions and Alliances from Datrium. Mike and Andrei, are you there?
Yes, we're here.
Yes, thank you.
Thanks for being on. Take it away.
Great. So today we are going to talk a little bit about the evolution of the data center and how we got into hyperconvergence and what lies ahead of hyperconvergence and why we here at Datrium believe there is an evolution cycle going on, and that hyperconvergence was kind of the first iteration of this type of integrated architecture, and why we believe what we are doing is far better and far more scalable and more performant than traditional architectures in hyperconvergence. So with that said, let me take it on. So if you remember, in the past, applications used to run bare metal on standalone x86 servers, and we had individual hard drives in each one of those servers. Life was, simple but also very siloed. But things changed drastically when a company called VMware created hypervisor, or the ability to create virtual machines and run independent workloads on the same server on x86 platform. That enabled us to consolidate many of our applications on top of those servers. The problem is that we quickly figured out that those hard drives that were available in those individual servers were not enough to cater for the demanding applications in those servers. So eventually we started using SAN for that, and the biggest reason why SAN became actually very prevalent in the hypervisor world is because VMware also invented something called vMotion, which enabled you to migrate between applications between servers. I mean, this is a long time ago, but SAN was already available out there, but it was not very used. And because you needed a shared storage to be able to vMotion those applications between hypervisors, SAN became very prevalent. Now, I believe we're having some issues with the animation here, but I'll go ahead anyway here. So what happened is, once we start moving all those applications to the SAN, we quickly figured out that initially the SAN performed great, and we had the performance that was needed for all the applications running on the x86 servers, but soon we ran out of performance, right? So we needed multiple different SANs in different environments, and it was very hard to scale when there were silos, and a lot of complexity as well. But the biggest problem around performance was not solved. But then Flash came along, and we said, you know what? Let's put Flash as a caching tier of our SAN and serve hot data from there. And that worked well for a little while, but applications got more performance hungry, and the whole virtualization became more prevalent in organizations. So some organizations, some companies, some vendors looked at this and said, well, this is not enough, so let's make it a all Flash SAN and cater for the applications. Flash is very good at performance and very good at latency, but the real problem was never solved, which was a bottleneck with the SAN controllers. Most SAN solutions will have two controllers, and the fact that you still bottlenecking your performance behind all those SSDs is a problem. So some companies looked hard at this and said, you know what? It doesn't make sense to have this bottleneck. Let's move the controllers, there are physical controllers in the same time frame, as a software stack into the hypervisor and have SSDs on those servers locally attached and make it a distributed architecture. And that's how HCI was created. Some well-known companies out there are still, selling this sort of solution, and there are many other companies that are doing this. But the problem is, applications also have big data sets, and especially when you start thinking about Oracle and SQL Server, and those SSDs in the servers were not enough for those applications or for that data set. And clearly it became very expensive at that point in time to make all-flash hyperconverged solution. So what they did is they added disks, and they would create a caching mechanism to keep the hot data on the SSDs and then the cold data on the disks. So the problem with this architecture is, first, for hyperconverged solutions, you generally speaking need to buy their own hardware or their specific HCL, so there is a hardware lock-in. The second point is, in the same time frame, servers used to be stateless, so there was no data actually being hosted on the servers. The data was all on the SAN. So if a server failed, you just power on that virtual machine in a different server. You're not really concerned about data resiliency. With hyperconvergence, servers are suddenly stateful, so data is living in those servers. So if you lose a server, you actually putting data at risk. And to be cost effective, vendors will tell you to do 2 copies of the data across the cluster instead of 3. And there's a lot of discussion around data resiliency and how many copies of the data you should have in a HCI or a SAN solution. SANs have been using RAID 6 and N+2 parities for a long time, but a hyperconverged vendor is trying to convince you that 2 copies of the data, or what's called 1FT, is enough for resiliency. The fact being stateless to stateful was a big change. Also, managing hyperconverged clusters from an infrastructure perspective is very complex. So there is a lot of metadata to be handled, and most vendors will tell you, we'll do petabytes of data, we do thousands of servers. Yes, that's all true. What they don't tell you is that those are all in small management failure domains or clusters, because it's very complex to manage all that at scale. Also, there is the forklift aspect. You can't bring your own environment. You need to forklift your environment, your solutions, your applications into this new environment. So generally speaking, you start with a pet project. You can't just bring hyperconverged as part of your environment, of your solution. And because of this metadata handling, and also a lot of east and west traffic, so because all nodes talk to all nodes, many companies that are doing large-scale HCI deployments end up having to re-architect their networks to handle east and west traffic. Most data centers today are handling north and south traffic, so there is this aspect as well. I'm seeing a lot of things that hyperconverged created that seem sort of like not really good, but there is a lot of goodness also about hyperconvergence. So they solved a lot of challenges in the data center. So they simplified, they automated, removed zoning, LANs, all the complexity and silos that administrators had to handle in the same time frame were removed. And some of the hyperconverged vendors went further and automated like patch management, hypervisor upgrades, firmware and BIOS upgrades, and this is all great. That said, most of the hyperconverged vendors that are on the market today, they created a solution to test the market. That's why we call the 1.0 generation, right? And it worked well for them, and they found a few different workloads that were very well fitted, like VDI. But the real problem here is that most of them evolved from there. So there is a lot of bolt-on services on top of file systems, as an example, that were not originally designed for that. Now, like adding compression, deduplication, replication, erasure coding, and all those services that are considered table stakes in the data centers today. That said, they work. That is not saying that they don't work. Finally, you clearly can't scale in different dimensions, right? For the most part, when you add compute, you add in capacity. And you add in capacity, you add in compute because the disks and the capacity are in each one of the servers. And some of them will also require strict networking. You need to, you can't really play with your networking vSwitches if you're using VMware as an example. It needs to be their own configuration, and there are issues if you actually make changes to that. So Datrium was founded by a couple very early VMware engineers and some founders of Data Domain. And they looked hard at this problem and all the issues that hyperconvergence created in the data center. And they looked at also how companies were moving from SAN. And they created a solution that enables you to scale performance independent from capacity. So the same way hyperconvergence believes that flash should be on the host, and a software controller should also be living on the host. So we should leverage the power of Intel when it comes to performance and data services. They did the same thing. The only difference is that we wanted to make sure that the servers were still stateless, so there was no data at risk when there were server failures. And we also wanted to create a concept of primary and secondary storage, and that's what I'm going to talk a little bit here. So the solution that we created scales out linearly from a compute perspective, so you add more compute with local attached flash, and you can bring your own servers, your own existing investments in the data center into the solution. And it scales capacity with what we call data nodes. So you create a data pool that has global deduplication across this cluster. So what we actually effectively created here is a solution that enables you to have local access to the data on SSDs or NVMEs. Some of our customers have been using NVMEs for over a year now. So all the reads are local. And all the writes, instead of going across a pool of servers, one write goes local to the SSD, and one write goes to this data pool, and it's fully erasure coded with distributed erasure coded. So we're providing the same type of resiliency that SAN provides today, instead of the two copies that hyperconverged vendors are saying that how you should handle your data. Now, because we also don't talk between the servers for the most part, there's no east and west traffic, so there's no major re-architecture or impact on the network. So it simplifies the solution, but at the same time enables you to have much larger clusters. So as an example, and I'm going to tell you a little bit later, you can go from one compute node and one data node to 128 nodes and 10 data nodes in a single unified system. Now, the beauty of the whole thing is that this is not only VMware, or this is not only Red Hat, and this is not only CentOS and KVM. You can run all hypervisors at the same time on a single platform. Sure, VMDK files only work for VMware, and certain files work only for Red Hat as an example. but many large organizations have multiple different solutions, and they can leverage this environment for all their hypervisors or for the entire virtualization set. Now, the interesting thing that I want to talk here is the concept of primary and backup data. And of course, this will only apply if all your data is living on Datrium, which for many organizations will not be the case. There are multiple different solutions out there today in the data center. But if you think that the VMs are running on the servers and we have a copy of the data in each one of the hosts, deduplicated, compressed, erasure coded, and then you have a copy of this data out of this compute cluster, stored and protected in this data node pool, you effectively have primary data running on the servers and backup running on that cluster. So in many cases, we are replacing third-party backup tools used in the data center. But if you rather use your Veeam or your Cohesity or your Rubrik, you're more than welcome to do so. And in many cases, you have not only Datrium in your data center, but you have other solutions there. Just for fact here, you hear many hyperconvergence vendors saying this is what web scale vendors are using today. It's not. This disaggregated approach of compute and capacity is what actually like Amazon and Facebook and Google are using today, at least for the past 7 or 8 years. This is actually what's being used in the data center. If you want to confirm that, just Google it. Look for Facebook Open Compute Platform and Bryce Canyon shelves, and you'll see that most of those web scale companies are actually moving in the direction of disaggregated hyperconvergence. They tried and it did not work well for them. So just a little fact here. But we are also very happy with some of the announcements that we've made in the last couple weeks. So we did a audited performance benchmark with IOMark, and we are proud to say that we are the fastest storage subsystem solution in history. Compared to the fastest array out there, all-flash array, we are 5 times faster and lower latency. And compared to the highest performing solution in the HCI space, and that test was done with Optane SSDs, Datrium is 10 times faster. So this is really groundbreaking in terms of performance and resiliency and scalability. And those tests, to be honest, didn't even hit the maximum that our technology or our solution can actually achieve. But it's not only about performance and resiliency, right? There's a lot of aspects to managing data centers, and that's where HCI really shine, which is the simplicity. So we built, as part of the solution, full VM awareness and analytics. So you manage your virtual machines and workloads at a VM granular level, like even the snapshots and backups, everything is granular. We have all the automation around one-click software upgrades, firmware upgrades, and the table stakes data services that are required today, like inline deduplication, inline compression, inline erasure coding. And as I said, we do believe that Flash or NVMe should be on the host. So we have the concept of data locality, so data will always be in the host where the application is running. We have encryption and multi-site replication. And if you're running VMware, our HTML5 UI is fully integrated into vCenter. If you're managing KVM or Red Hat, RHEL, you can use that as a standalone user interface as well. But for the most part, there's really nothing that needs to be done in the environment once it's configured. All the data services are on by default. We want to make sure that everything is very easy and simple. So as I mentioned, you can bring your own compute solution, your own data center environment, connect to the data nodes, and we deploy what's called a hyperdriver into your compute node, into your hypervisor, and from there you can start using the solution, and you can share also with your SAN environment. Go from 1 to 128 compute nodes and up to 10 data nodes with 1.7 petabytes effective. We are somewhat a new company, and I know you're getting a lot of media attention right now, but we do have, lots and lots of customers, and we have Fortune 100 companies as customers as well, and they are in all sort of verticals, and we see uptake in all of them. And of course, we couldn't be here without a rich partner ecosystem. We've been working hard on that, and trying to certify and validate and benchmark as many applications and as many partners as possible to make sure that we give you the feeling that the platform is supported and will perform under any conditions and supported by both vendors. Okay, so I think that was a good introduction to Datrium and also to the evolution of the data center, why we move away from SAN to hyperconvergence, and what is happening in this space, and how we are trying to solve some of the gaps that hyperconvergence created. I would like now to invite my colleague Mike McLaughlin to talk about split provisioning and also give you a demo.
Thanks, Andre. So for the last part of our session here, I want to just kind of cover a couple things real quick and put in context. I've got a couple of short demos that I'll share with you. And if there's more information, you can always request one from our website. But split provisioning is a fundamental architectural approach that we've adopted or put into the product to essentially allow you to scale compute or capacity independently, kind of the top and bottom of this particular slide here. And the two demos that I'm going to show you here, one is I'm going to essentially take an environment and add additional hosts into it and show you how simple that how simple that is. And then I'm going to take another environment and I'm going to add another data node into it. So I'm going to add compute nodes into one demo and data nodes into the other. And I think with that, we'll just let this roll, and hopefully the demos will present well. And if not, and if you'd like more information, I'd like to see it a little bit more in depth, feel free to get back to us and drill in on that. But for now, let's take a look. So the first demo, we're going to essentially start with an environment and add compute nodes. And I think if I click this button, it's going to begin playing here. So on this one, I've got an environment already set up, and I know it's a little small to see here, but this is my vCenter. I've got a host running over 100 virtual machines on it, and we can see here I've outlined the box. This is one of our Datrium compute nodes. And what I want to do now is essentially expand this particular desktop cluster, for example, and I've got 3 other hosts in my vCenter environment that are sitting there ready to be organized into my problem space, into my solution that I want to do here. And each of those are also Datrium compute nodes. What I'm going to do now is go to the Datrium DVX dashboard, and this is the top level. You'll kind of see the stats here. I essentially have 1 data node and 5 hosts in there. There's the one that we saw that was already configured in. But if I go simply to the admin gear and I want to add hosts, here's those 3 hosts that I just showed you that were sitting sort of on their own in my vCenter environment. And it is simple as selecting those hosts. We're installing the DVX software on them right now, basically turning them into DVX-capable hosts in this environment. What's going to happen is we're going to install the software. It's going to discover the local flash drives that we see here. These are SSDs that are on those hosts that are going to be turned into local storage through our DVX software. And I'll basically say, go ahead and select the ones that were selected there. And what's happening now is those flash drives are essentially being integrated into the solution and being put in front of the data store that we manage in the overall DVX. So now that we've mounted the DVX data store, I now have my original host and 3 more that are basically part of what I'm trying to do here. And I can simply now go back to my top level environment and push those 3 new hosts into that desktop cluster, for example. All right, so now my one host that was sitting in there running over 100 virtual machines now has 3 more DVX installed hosts. And it really is just that simple to take hosts out of vCenter that are discovered that have SSDs in them and essentially bring them into service into the DVX. So we're doing this all within the vCenter environment. That's another thing, just from a simplicity point of view. We essentially stay within vCenter, and now we can see that we have this one data node, and now we have 8 hosts and over 100 virtual machines that I'm free now to move around and deploy those hosts as I want. So the point on that one was fairly simple. Hosts in vCenter with SSDs in them can be added to the DVX by simply having us push software onto those hosts and convert those SSDs into local storage onto our data store. All right, so if you think back to that split provisioning slide, that's the top level where we scale out hosts, and I can go up to 32 on a single data node or up to 128 in the DVX cluster. This next little demo presentation here, and this will just take a minute or two, basically is going to add capacity. So in my environment, I may have a data node, and here we've got a DVX with just one data node and about 26 odd terabytes of capacity. We can see that on the top left. And what I want to do is add another data node. I simply go to the admin gear and I say add data node. It looks out on its local network for other data nodes that haven't been configured yet. And all we need to do is basically select the one that we want, provide some IP addresses so we can talk to that data node, and say add it to the data nodes set. What's going to happen now is the 2 data nodes are essentially going to form a single larger data set, all right, and we can see them now in this window, and the second data node is rebalancing. So we're actually moving the data from one data node over the 2 in the environment right now, and that's all done in the background. So I essentially went from a 26 terabyte to a 52 terabyte environment by simply bringing a data node into my infrastructure, putting it on the same network as the first one, and having the DVX discover and configure it into a larger pool of data. Now, those network addresses that I gave on there also give me some more throughput to it. So as I scale out compute on the top line, like we just saw with adding compute nodes, or I scale out capacity on the bottom line, as I just saw with the data nodes, I'm also scaling out the performance and capabilities of the entire DVX cluster. And that's really it. I mean, just a little insight into how we're doing this, and the architecture that we have is essentially separating the host and the data and putting the actions at the right level. And that's part of the DVX open converged architecture that Andre kind of gave you sort of the roadmap as we've evolved into that. And I think with that, we're about at the point where we want to stop and take any questions. I know that we've been answering some as our session has been going on. Do we want to open that up for questions on the line now, or we can just continue to answer those off the Q&A session? I'm going to turn it back to you guys at ActualTech Media.
Okay, yeah, great presentation, really cool demos. Thank you for sharing those. We do have a number of questions for you from the audience. I see that you have been answering some of them. Let's see what's left here. Question that came in here is there a plugin for vSphere, or how do I achieve that sort of centralized management?
Yeah, so actually, the demos that I just showed you, there is a standalone UI if you wanted to get to it without your vSphere environment. But we actually plug into your vCenter. Your vCenter, we essentially introduce the DVX to the vCenter. Our plugin goes in there. You never have to really leave that environment to manage your virtual machines, their storage, or the DVX. So yes, there is a plugin, and the vCenter plays a very integral role, as you saw in the demo there briefly, of finding the parts that we want to put together.
Got it. Very nice. Another question here is about the hypervisor support. What hypervisors do you support again?
Yeah, so we support today VMware vSphere, KVM with CentOS, and Red Hat Virtualization, REV. Those are the 3 options that we support today. And we also support bare metal Linux with containers. So there are many companies out there that are looking at containers, and they start their journey into containers with virtualization. But over time, they want to harvest that additional 5 to 10% performance of running continuous bare metal, and we can support that transition too.
Okay, excellent. What about the storage protocols? Like, what storage protocol does Datrium use to communicate? I mean, for the hypervisor to communicate with the storage.
So interesting. So the storage protocol is actually, I'm going to say it's proprietary. We're presenting vDisks. So in the VMware environment, or even in the Red Hat Linux environment, we're essentially presented as an NFS data store, but that is only to the hypervisor. So there really isn't a storage protocol that has to be sorted out or set up. We essentially handle all of that. So the thing that you're really focusing on from a storage perspective is getting the virtual machines on our data store or on our mount point. So I kind of saw the question here. There's no fiber channel, there's no zoning, there's no LUNs, there's no volumes, there's no HVAs that have to be put in. Basically, we have a 10 gig Ethernet between our compute nodes and our data node, and we form the actual communication boundary, but we present that as an NFS repository to all of the hosts sort of above the line.
Yeah, technically it's a NFS loop, local NFS loopback.
Yeah.
Okay, so all that traditional storage administration with a traditional SAN, that all goes away.
Pretty much. In my demo, you saw how quickly I added storage and I added hosts, and I wasn't doing really any storage operations. I'm going to manage them at the virtual machine level. I'm going to create virtual disks through my vCenter or through my Red Hat Virtualization Manager, for example. Yeah.
Very nice.
Storage gets very simple.
Okay, and let's say that I wanted to use vSphere and move Datrium into the data center. Kind of, what are the requirements? Like, can you walk me through the process of, say I have a traditional SAN and some vSphere hosts, how would that change? How would the architectural design change there?
So to get started, so you need vSphere 5.5 update 2 or later, so something relatively recent. Your vSphere host would need to have a 10 gig connection to the network somewhere that we could hook our data node onto. And it would need to have at least 1 to 10 internal SSDs. We have a requirement to have some flash on that host. So 1 to 10 devices, 800 gig to 16 terabytes in size. You kind of figure that out, because that's what's going to basically front the DVX data node. Then all you would need to do is put our data node into your network and introduce it to your vCenter, and pretty much everything from there you saw in the demos here would be to add the hosts or add more data nodes, and it would basically form that relationship for you. So the minimum requirements, again, vSphere 5.5 update 2, at least 1 flash device and 10 gig network. The vSphere host really needs to have about 8 core on it, so it has to be relatively, I'll say, not too old, but at least 8 core total in processing power, so that we can run vSphere and the DVX software.
Nice. And is the built-in data protection and replication, is that sort of replacing existing, say, backup and disaster recovery type solutions? Or can it?
It can, and I would say augmenting it is definitely in the program. Replacing it in some cases. So the DVX, the data management services, include local snapshots, replication to other DVXs. We've got a very robust and rich mechanism for building policies around that. You can get crash consistent backups, VSS application consistent backups, and we can get that down literally like to the 5 or 10 minute RPO point if you want. But we're not a full backup application at this point, and there are still some situations and environments where there may be platforms we don't support or applications that you want to integrate to. So I kind of look at it as the belts and suspenders, backups and snapshots, really to give you the best leverage of effectiveness and timeliness of what you're trying to do.
Okay. What about scalability? There's a question here about scalability. I know that Andre and I recently talked, and we did an interview about the scalability tests that you all have done. Can you refresh our memory? What are the official scalability limits of Datrium?
All right, so scalability, a data node can support up to 32 compute nodes on it. All right, so you have to start with at least 1 compute node and 1 data node to form a DVX. So on the lowest end scalability, the smallest thing you can build is 1 compute node, 1 data node. On the higher end, that single data node can have up to 32 hosts attached to it. I can string up to 10 data nodes together in a pool on the back end, and as I get to at least the fourth data node, I can put up to 128 compute nodes into a single DVX cluster of resource. So we're well within the boundaries of what you would manage probably within one vCenter environment as well.
Very nice, very scalable. And then what if I run out of space or I don't want to pay for more, capacity on premises? Can I move anything up to the cloud?
So that's a qualified yes. So we actually have replication to the cloud. That will be in our end-of-year release. So that has been demonstrated, and we've got it running in some sites right now. That is a capability that we essentially want you to be able to replicate from a DVX to a DVX or a DVX to a cloud-based DVX as well.
Okay. Question came in here about encryption. Is there any sort of encryption available?
Absolutely. The data services, data deduplication, compression, erasure coding, always on. All right. One of the storage administration choices that we still leave up to our users is whether to encrypt all the data or not. So a DVX environment has an encryption capability which right now will encrypt all of the data on the DVX, on the data nodes, on the compute node flash, and on the connections between the compute node and data nodes. All right. And so that's essentially a very simple thing that you can choose to turn on or turn off.
Okay. And I want to call the attention to the audience out there to the question on the screen. It is, would you like to learn more about Datrium's open convergence solution? If so, just click sure right there. We appreciate you answering that poll question. Another question here is about what's the entry point for Datrium typically? What's the typical use case where people say, hey, I really want to put Datrium in my data center?
A good question. So the data node starts, as you saw in the one example here, at 26.4 terabytes. We are looking at possibly making smaller ones, but that typically you're looking at about, let's say, a 30 terabyte addressable storage for your primary and possibly snapshot protected data. Because we scale by adding hosts and bring host performance into the mix, I talk to my customers, I say the fun starts at probably 3 or 4 compute nodes, and that's where you're really starting to move past other technologies. A single host, single compute node, single data node, you can certainly start there, but the ability to move workloads around and expand and literally bring more horsepower in by adding hosts, I'd say at 3 or 4 it starts to get very, very interesting, and as we scale up into the dozens or more, we have some customers running some fairly nice clusters against single data nodes.
Okay. So if your SAN is outdated, needs replacing, consolidation, storage consolidation, are those common with Datrium?
Yeah, typically we'll find it is either the technology refresh. Somebody bought some storage 3-4 years ago. Maybe they have flash out on their storage array, or they're refreshing their servers and they're going to get a little bit more horsepower there, and they're trying to figure where do I put flash in my new data center? Well, putting flash in the server makes sense to us, and those servers then can hook up to a DVX data node for the persistent copy, and it's very easy to basically vMotion over onto a Datrium data store and take advantage of everything that we provide. We see that in consolidation. We see it in a lot of workloads that would run better if they could get sub-millisecond latencies on a regular basis. We have a lot of customers that once they deploy Datrium, they're running their workloads on the host in local flash, and they're seeing really nice results both from a performance and a latency perspective. So it's a great time for a technology refresh and literally put flash where it belongs, in the host.
Very nice. And what's the recommended step for people out there who are interested? Is it to request a demo on your website, or what do you recommend?
I'd say that's probably the best start is visit the website. If the information there through product specs and white papers isn't sufficient to do a little background reading on your own, click the button and request a demo. We'd be happy to talk to you. I mean, you can certainly get an on-site evaluation. It does require a piece of hardware, so our DVX data node kind of gets the thing kicked off, and we can work that either internally or externally with you. But I'd say see if the information that you're looking for is on our website, or give us a call.
Excellent. Well, really great demonstration. Thank you so much. There's some more questions left for you there in the queue if you don't mind checking those out.
Yeah, my colleagues here are busy typing into the window, so we're double teaming here.
All right. Well, thank you, Datrium.